Hello and welcome to SudoKanard. Let's have a look at this killer Sudoku by some Cappleman-Lynes for United Kingdom Sudoku Championship of 2022. I couldn't solve the puzzle during the contest because I failed to see something that I had seen. That's complicated. Then let's move on to the puzzle. Let's not talk about it. So there's a trick at work in this puzzle, which is something about geometry. First, let me recall the rules. Whenever you have such a cage with a dashed outline, the digits must be all different in this cage. So we have 7 different digits in here, and their sum is given in the top left corner of the cage. So the interesting part in here is that here we have 7 different digits, and here we have 2 digits that are both different from those 7 digits. And considering that, those 2 digits are the 2 missing digits in the cage. And another consequence of that is that those 2 digits must appear somewhere in the row, and they're not in here, so they must be here. And once you know that the sum of all 9 digits is 45, you know that the sum of the 2 digits here is 5. So they are either 1, 3, 1, 4 or 2, 3. And the same is true here. And we have something similar in here, which is that those 2 digits are the 2 digits that are missing from here, and their sum is 15. So they're either 6, 9 or 7, 8. And the same is happening here. Those 2 digits are either 6, 9 or 7, 8. And that gives us something to begin with, which is that this digit is in the 12 cage with a sum of 12. That's twice the same thing, yes. And this digit is with 3 other digits with a sum of 12. But the sum of the remaining 3 digits is at least 1, 2, 3, which is 6. So this has a maximum of 6. So this has to be a 6. And for a sum of 15, this has to be a 9. And then the remaining 3 digits must be 1, 2, 3. Which means that this has to be a 4. And for a sum of 5, this has to be a 1. Now, considering this, we know that this 12th cage is not 3 plus 9, it's not 4 plus 8, it can only be 5 plus 7. And this can't be a 9, so this has to be an 8, and this has to be a 9. This 8 now removes the possibility that this be a 6, 9, 7, 8 pair, so that's a 6, 9 pair. And now by the same argument as with the 12 cage, we see that this can never be a 9, because with a 9, the minimum sum of this cage would be 15. So that's a 6, and that's a 9. And we still need to figure out what the other digits are. It could be 1, 2, 5, they could be 1, 3, 4. And we don't have enough information at this point to decide on that. But something interesting is here. This 11 cage is made of an odd digit and an even digit, and considering this and that, we see that the only value for the odd digit is 3, paired with an 8. Let's move on to this. We know that 15 in two cells must be 6, 9 or 7, 8. We also know that 14 is 2 cage in 2 cells, is 6, 8 or 5, 9. So you see that 6, 9 here wouldn't work, because 6, 9 would just rule both of those options out. So this is not 6, 9, this is 7 and 8. Now it can't be 6, 8 anymore for the 14. It has to be 5 and 9. Now let's recall Oh, we're missing something. This can't be a 1, so 1 is here. Alright, so what was I saying? So this 40 cage does not have the 1 and the 4. It must have all other digits, 2, 3, and digits from 5 to 9. So none of those digits are in here. So those 4 digits, those 3 digits must be 2, 3, and 6. That's the first thing. And we have 1, 4 pair in here. And 5 and 9 must appear in the cage, but they are not in here. So they must be here and there. And the remaining 2 digits are 7 and 8. And actually 8 is not here. Those are from 5, 6, and 9, and this is not 9. The digits here now must be 7 and 8. And the interesting part is that this 13 cage now is not 7, 6, it's not 8, 5, it must be 4 and 9. Which means that this is not 4. And we had 2 options for the remaining digits. One of them was 1, 3, 4, and we must eliminate this one. So the only remaining option is 1, 2, 5, which means that this is 3 and this is 2. So there's no 2 here, and there's a 2 there, and this is 7 or 8. This disambiguates the 3, 8 pair. And 8 and 9, which do not appear in here, must be somewhere in the cage, so they are here. This 5 here is not 3 plus 2, it has to be 1 and 4. And it disambiguates some more. The digits here are 2 and 6. 12 cage here does not include the 4, does not include the 5, so it must be 3 and 9. And something I'm seeing here is that we have located a 9 somewhere in here, somewhere in here. So for those 2 columns, we have located 2 instances of digit 9, and we know that there must be exactly 2. So we won't have a 9 anywhere else on those columns. And using those 9s, we see that 9 in this cage, in this box, can only be here. And we see there must be a 6 somewhere in here. But that's a story for another time. Something else I'm seeing is that this 8 must appear somewhere in the 30 cage. So it can only be here. And this disambiguates the 7, 8 pair. So that's a 7 and that's a 3. So that's a 2 and that's a 3. And actually this is a 1 with a 4. And we get the 4, 1 there at the top. What is the next step? Well, similarly as to this 8, 7 is not in here, but it must appear somewhere in the 30 cage, so it's here. This 9 makes this a 5, this a 9. This row still needs a 6, and this row still needs a 2 and a 1. Next, here we need 4, 6, and 7. 6 can only be here. Here we need 1, 2, 6, and 4. 1 and 6 are not in here because of that. So 1 and 6 are in here. So that's the 6, that's the 1, that's the 2. And here we need 4 and 2. So that's a 7, that's a 4. This is 8, with 7 and 8 in here. That's not a 2. Up there we need 5, 6, and 7. I forgot to type the 6, and that's not 7. So the puzzle is not yet finished. This 6 makes this a 6, this a 5, this a 6. Here we need 2, 4, and 5. So that's 4 or 5. And something interesting here is that this digit here is nowhere in those cells. But it must appear somewhere on this row, so it must be here. Well, that's not so interesting, given that this was a 4-5 pair anyway. But I just liked to see this kind of geometric deduction. Here the missing digit with the 6 is a 3. That's correct. Oh, and we get a 3-6 pair in here. So that's a 9, with a 3, 6, 3, 6 here. And that's a 5 and that's a 9. And this now can only be a 7. That's a 5, that's a 6. We get the 2 and the 3. So how do we finish this? Here I need a 1 and an 8. So that's a 3, that's a 1. Here I need a 2 and a 5. It's so easy to mess up at this point. And now this 7 has to be here, so that's a 4. 5 and a 4, 2 and a 5. This 4 makes this a 5. This here is a 3. And then you could think that that's a deadly pattern. There are 2 solutions. But no, because this is a cage, and all digits must be different within the cage, so that's a 2. And that's it. So if you notice this geometric deduction at the beginning, the solve is rather smooth. This is what I only partially saw during the contest, which is why I just failed to solve it and I wasted quite a lot of time. But this was my failure, not Sam's. Sam's accomplishment is, well, up there. Thanks for watching this video and see you soon on SudoKanard.